Let's turn our attention now to elimination. To solve by elimination, in order to get started, both equations must have y alone on one side of the equal sign. That's the case here. I see y by itself on one side of the equal sign and y by itself on one side of the equal sign. So I'm all ready to get started. Next, I multiply the second equation by -1. I took the second equation here, put it in a nest with a -1 outside. This may seem strange, but I do this in order to make the y's opposite. In math, opposite means opposite signs. So for example, the opposite of +2 is -2. The opposite of -4 is +4. The opposite of -x is +x. And the opposite of y is -y. I wanted y and the other y to be opposites, so I have to make it -y. Hope that makes sense. If it doesn't, stick with it. It will come. Okay, so again, I put my second equation in a nest with a -1 outside, and then I have to distribute that -1 throughout the equation. I use distribution, also known as the rainbow rule. And -1 times y gives me -y. -1 times 4x gives me a -4x. After we've distributed the -1 throughout the equation, I stack the first equation just below. So there's the equation I stopped with on the last page, and I stack my original first equation below it. You'll notice that the spacing is a little strange. This takes us back to combining like terms in our jingle, birds of a feather flock together. You'll note that in the second equation here that I listed, there was no variable x with an exponent of 1. There was no match, so I made sure not to stack any term just below -4x. X squared did not have a match, so I put it on the second line out in space. Same with my constant, the number 4. Once I've stacked them, I draw my line and combine. I drew my line and I combine straight down. -y battles a +y, gives me 0. As is always the case in math, opposites negate each other and leave us with nothing. -4x has no like terms, so it simply comes down. Same with x squared and my constant 4. Now I write it in standard quadratic form, going from greatest degree of 2 to smallest degree of 0. And I use the quadratic formula to solve for x. You should all know the quadratic formula by now, but just in case, we can practice together one more time. -b plus or minus the square root of b squared minus 4ac all over 2a. You can see here in this example, a, which is always in front of x squared, is the mysterious, magical, and invisible number 1. B, which is always in front of our linear term, our x value, is -4. And C, which stands for constant, is 4. I substitute those values into the proper place within the quadratic formula. Note that when it says -b, because b is already a negative times a negative give me a +4. That's a common place where students make mistakes. Don't let it happen to you. And as we all know how to do now, I simply simplify my quadratic equation. I start inside the radicand. -4 squared is a +16. 4 times 1 times 4 is 16. 16 minus 16 is 0. The square root of 0 is 0. and 4 divided by 2 is 2. Take some time. I know you're not all moving that quickly through this process, and that's okay. And the point of this video is that you can pause, replay, rewatch as many times as you need so that I go at exactly the speed that's perfect for you. Since x equals 2, as we found on the last page, we substitute 2 for x into one of the original equations. I chose this one because it's simpler. Where y used to equal 4x, now I'm substituting 2 for my x value. Beep-boo, babu, babu, beep, and I find that y equals 8. I write the solution as a coordinate point xy, 2, 8. That is the process of elimination. Last but not least, we'll talk about substitution. And don't worry, it's a bit shorter than elimination. I know y'all will be telling me, Ms. P, we're doing too much. Hang on, we're almost done. To solve by